Well, welcome to Mission Control in Houston. My name is Pat Ryan. I'm the Public Affairs Officer on the Orbit 2 shift here in Mission Control today. And we just finished up our daily update of the news on board the International Space Station. And looking forward to talking to you about the station and about space exploration. Brought along somebody who knows all of that stuff even better than I do. Eric Bowe is an astronaut. He's been an astronaut since 2000. He's flown to the International Space Station twice as the pilot on Space Shuttle Endeavour in 2008 and on the very final flight of Space Shuttle Discovery in 2011. But perhaps more important, Eric, is tell us where you came from to get here.
Well, I grew up in Atlanta, Georgia. I lived on the northeast side of town, went to Evansdale Elementary School, and graduated from Henderson High School, which is now a middle school in Atlanta area.
So you are familiar with the area where the folks here from Ball Ground are.
Absolutely, very familiar with the Atlanta area. I was looking at Ball Ground where these guys are location-wise. My father actually lives in Canton, which is pretty close to where they're at.
Tell us real quickly, how did you become interested in being an astronaut? What did you have to do to get here?
Well, I've always been interested in flying. It's just been one of my passions, and so I went into the Air Force and became an Air Force pilot. It was always kind of a far-off dream. I remember my parents coming when the moon landings happened, and Neil Armstrong was walking on the moon, calling me in and saying, "Hey, watch this on TV." And it's kind of my first recollection of television. I remember seeing the landing, and I think that's was always kind of on my mind to maybe get a chance to do that in the future. And as my career went along, I became a fighter pilot and a test pilot, and I had the qualifications to be an astronaut. I went ahead and applied, and that's kind of the course it took.
Cool. Well, let's find out what the kids in the Atlanta area are interested in. We're ready to take your questions.
What kind of training do you do to become an astronaut, and how many years do you have to train to be an astronaut?
That's a great question. Well, the training is involved. Usually when you come in as an astronaut, one of the first things you do is you go through astronaut candidate training. So that's usually in the range of a year and a half to 2.5 years, depending on how that works out. So you do all kinds of generic training, things like working the robotic arm. You learn how to fly. We have T-38s that we use for training to get crew members used to what it's going to be like on a spaceship, because communications and working those things. We also have a neutral buoyancy laboratory, NBL. We'll talk about that probably a little bit later, where we practice doing spacewalks as well. And we have a lot of other training, language training now with the International Space Station. Russian's one of those big things that we're learning on the station. So that training. And then as you pick up jobs in the astronaut office as you wait to be assigned for your flight, and then you get assigned a flight, and then that training right now for the International Space Station is on the order of about 2 to 2.5 years for your training that's involved. When I was a space shuttle pilot, my training for the space shuttle mission was about a year to a year and a half. So it kind of depends on what you're going for. You know, space station missions, about 6 months is how long it lasts. So it just takes a little bit longer, especially because you have travel between different countries. Did I answer?
Yes.
Okay.
Yes. Next question.
What is it like training in water, and how does it relate to being in space?
Yeah, well, you mentioned the neutral buoyancy laboratory. That's a big bucket of
Absolutely.
water.
It's one of the biggest pools in the world, and it's gigantic. If you ever get the chance to come out here to Johnson Space Center, you can take a tour of it and actually see it. It's really gigantic, and even though it's a really big pool, we can't fit the International Space Station fully in there, so we actually have to put the mock-ups in different locations. But the thing the pool allows us to do is to get out there and practice three-dimensionally like we're going to be in space, whereas if it was some other way, you obviously can't float on the ground. Well, what they do is they balance you out in the pool, and so it kind of simulates like being in space. Things that the pool doesn't do very well is one thing that you get in the water is obviously drag. You know, you move your hands in front of you and it slows you down. So in space, these are things that you have to compensate for. And most crew members, when they go out the first time they go outside in space, they have to really concentrate to look at those differences and make a difference. But we found the pool is the best way to simulate space that we can do on the ground with the best trainer that we have.
Did you like scuba diving before you started training with it?
That's a great question. I did like to do scuba dive. I was stationed in the Air Force on my first assignment as an operational pilot, and I was in the Philippines, and that's where actually I learned how to scuba dive, and I had a great time there. The scuba diving was excellent. So
beautiful.
Beautiful place to learn how to scuba dive, and I've continued scuba diving throughout my life. But we also scuba dive. Not only do we wear a spacesuit in the pool, but we also practice in the pool for our spacewalks by looking around at the mock-ups in scuba gear. So I really enjoy scuba diving, and I enjoy it both in our NBL and also out in the ocean.
And I'll point out that there are other people who are helping train astronauts who scuba dive. I had never been a diver before, but shortly after I came to work here, I got trained in scuba diving so I could go in that pool with a camera to shoot video of the astronauts while they were training. And it's a remarkable thing to be floating around in there uh, for a couple of hours at a time, holding a camera that's trailing this long cord and swimming around following them as they train for all of the tasks that they have to do on the spacewalk. You get a real interesting perspective of how that goes, and you also learn a lot about what they're actually doing on the EVA. So people who like diving can be involved even when they're not astronauts.
Absolutely. When we're out there just practicing, typically a spacewalk, we have 2 people that are outside, and when we're practicing, we have 2 people. But we have a whole team that's supporting that training that we're doing in the NBL. And so when we do that, we have, just like you said, photographers that are working with us. We have safety divers that are keep watching us. We have camera float photographers. We also have people talking to us on the loops that are not in the pool, but they're looking at some technical details. So we have a huge team that's helping us train while we're in the water. So absolutely, there's a lot of things to do here.
Who's next?
Is astronaut training tiring?
Astronaut training can be tiring. It's really a lot of fun. It's a lot of hard work. There are times when it, goes quickly when you're working really hard, and there's other times when you just got to do some brute force of looking at things and really studying things. But the pool that we just talked about, when you're doing a spacewalk, is because you're fighting against the suit. Typically, when you're in space, you have a pressure differential, which makes the suit kind of rigid when you're moving your arms back and forth. And so that really makes it, and doing things with your hands, like your tasks of squeezing with your hands, can be very difficult. So when you get done with that, whether you're doing a spacewalk in space or you're in the pool, you end the day and you're fairly tired. And other things like that can be fairly rigorous in our training.
Is the suit you wear heavy?
Yeah, that is a good question. It is heavy, actually. The white suit, when we go outside for a spacewalk, weighs about 300 pounds or so. So it's a fairly heavy suit that you got to move around. But you got to remember, when you're in space, we call it, you hear the term 0G or weightlessness, or we call it microgravity to be very specific. But essentially, you're weightless, and so that allows us to move the suit around. So the thing that makes it difficult to move the suit is that you're fighting that pressure that I was talking about in the suit itself. So you don't really feel the weight, and it's actually fairly easy to move. Our other suit that we wear a lot of times, like when we launch on a Soyuz or when I was launching on a space shuttle, we wear a different suit, and that suit isn't quite as heavy. It doesn't weigh 300 pounds. It weighs on the order of 30 to 50 pounds. But the suits that we do have some weight to it, and you have to work around them. They have some limitations that affect you, but that's why we do the training that we do.
And part of the reason that you said you have to work against the suit is because of it's pressurized on the inside. If you go out to do a spacewalk where there is no atmospheric pressure because there is no atmosphere, you have to have pressure on the inside of the suit in order to provide you with an environment that you can live in. And it's that pressure that makes it hard to operate, that makes it tough to work against the pressure on the inside of the suit.
Exactly right.
What materials do you use to make an astronaut suit, and what are its features?
Well, that's the suit is actually fairly complicated. Obviously, it's another team that went out and designed the suit. We've had several iterations of suits along the way, but the big picture for the spacesuit that we have, the one that we take outside to do our spacewalks with, is it's made out of layers. You start with a layer that basically is a bladder. It basically keeps that pressure that we've been talking about, keeps the air in. That's obviously one of the most important things, because you can't continue to live if you don't have a place to breathe. And so that's the big area. And then all the other layers are basically to support that layer. So then we have a layer that basically is a protective layer, so that if you bump into something, you don't accidentally cut that bladder. And then on top of that, we have kind of a mesh weaving that goes on top, again, that helps protect. And then there's a thermal layer that protects against the sun. And then on our gloves, where we grab things, we actually we'll put an additional, like a rubber layer that helps us, so that when we're touching things, that layer can help prevent us from getting cuts in our gloves. So the suit is a very complicated. And then obviously it's almost like a portable spaceship, because you have your own oxygen and breathing. You're basically self-sustained. You have a little power unit, a battery, so you can monitor your systems that's going on. And you have water to cool the suit while you're outside. So there's a lot of different things that go on to a spacesuit, and it's essentially like a little spaceship that you're taking outside.
I think it's also important to point out that you don't go to space and wear those spacesuits all the time. Most of the time, you're dressed like this.
Yeah, absolutely. We're wearing a shirt just like this on the inside, and it's just when you're going to go do a spacewalk that you actually put on that full suit. And typically, when you're riding up and down, you put a spacesuit on. But then once you're in orbit, a lot of times you take the spacesuit off, do some work, and then you put the suit on. So most of the time you're not wearing a suit, but there are times when you're having to do the spacewalk or special times that you put the suit on.
What is it like to live in? What is it like living in space, and how long do you usually stay up there?
Well, it's great living in space. It's one of the coolest things. You know, the living in space, there are so many things to see. Usually you're busy with a lot of work that's going on, but when you have some free time, the thing that you go out and do is you look at the Earth and you're amazed at how it is. But there's all kinds of things you have to think about in space: is how to eat, how to sleep, all the basics. I think there are a lot of different things that are involved in it. But for my flights, I went up for about 2 weeks, almost 16 days,
Right.
some of the longer space shuttle missions where we went up to the space station and stayed there. And we met crew members, like we have crew members on board now. We have 6 crew members on the space station right now. And they're up there for anywhere from 5 to 6 months is the typical mission while they're on board. So you really have to kind of calibrate yourself to how long it's going to be. When you're on these shorter missions, they're a lot more fast paced, but on the longer missions, it's still a high pace, but you do it over a longer period of time.
And in fact, we already have a crew that's been assigned that is in training right now for a mission that will last a full year in space. One NASA astronaut, Scott Kelly, and Russian cosmonaut, Mikhail Kornienko, are about to officially get started in their training. They're going to launch, and they're going to be up in space for a full year. Longer missions like that we're doing in order to better find out how people can spend a long time in space, because it is going to take a long time in space to go do the future explorations that we want to do, to go to Mars or to go to asteroids. It'll take a lot longer than just 6 months.
And in the recent times, this is some of the big things we've been learning about in space on the space station is actually doing these 6-month missions. We're doing a build-up approach as we get there, and so these things we're learning about a lot of things like bone loss, how to keep your muscles. Obviously, when you're in space, you're not using your muscles the same way on the ground. Just standing up on Earth is a workout. When you're in space, you don't have that effect. So we have other ways to do that with workout equipment, and we have a bicycle that we can work on and treadmill as well.
Okay, next.
What is it like sleeping in space?
Well, sleeping in space can be interesting. The first time, obviously, you're just floating in space. So usually, on the space shuttle, we actually took out sleeping bags. So it was kind of like being on a camping trip where you went out and put your sleeping bag up for the day. On space station right now, they actually have little sleeping quarters that they go into. So either way, you have a place that kind of keeps you in place, and that's just so you're not floating around bumping into things that probably wake you up. One of the things I always thought was kind of interesting about space is it could be they give you a pillow, but obviously in space your head would be like this off the pillow, and that wouldn't work so well. So NASA gives you some NASA-issued Velcro to stick around your head and attach yourself to the pillow. So it's kind of a fun way to make sure that and actually it's very normal. It feels like you're sleeping at home after a while, but you do have some interesting dreams while you're floating around, and and a lot of people like to curl up with their knees, kind of get in that fetal position. And again, we have some Velcro to get your knees in a position to kind of hold them there, because if not, they would just extend themselves out and wouldn't work the way you wanted to. But like anything, you learn how to adjust to these changes, and it's actually fairly easy to sleep in space. You don't have to worry about a soft bed like you do on the ground.
No kidding.
How do people on the International Space Station get food and water from Earth if they run out?
How do you get food and water? Well, the big thing, we were just talking, we have a ship that's planning to dock to come up to the space station. We have these unmanned ships that come up. The Russians have some. We have our international partners in the United States as well has one, and we're actually have a new commercial company, the Orbital Sciences, is looking at launching their vehicle coming up this summer. So we have different ways of getting food and water up to the space station. The big thing is planning. We don't want to get to that point where we run out of food and water on space station. Another interesting fact is on space station, a lot of our water actually gets recycled. We have a reclamation system on board. 90% of the water that we have that's getting used is getting reprocessed and redone, and it's really important because weight is a fairly expensive thing to get up and down, and the average human needs about 2 liters of water a day. So you start adding that up, that adds up to be a lot of weight of water. And so by reusing it, and these are some of the things that we're learning in space that we can use on the ground, because there's obviously places on Earth where water is limited.
And as Eric said, there's because the space station is run by a partnership of different nations, different countries are providing those supplies. The Russian partners launch one kind of cargo ship. The European Space Agency has one. The Japan Aerospace Exploration Agency has yet another kind of cargo ship. And NASA has provided the seed money for a couple of private companies in America that have been developing cargo ships. One of them is already flying, and the second one is about ready for its first test flight, its demonstration flight to the station.
Did you see the Great Wall of China while you were traveling through space?
I actually didn't see the Great Wall of China. The timing for lighting didn't work out that way, but there have been people that have seen the Great Wall of China, and actually with a camera you can see a lot of things on Earth that you know that humans are there. We're flying fairly low over the planet. We're at the range of about 200 to 300 mile up in space, depending on where you are in your orbit distance. So you're actually fairly low going across the planet, and you can see the Great Wall of China from space, but there are a lot of things that you can see that are man-made from while you're going around the planet in orbit. But the Great Wall of China is a pretty amazing one. It's on my list if I get the chance to see it when I go up there next time.
Okay.
Did you see day and night when you traveled?
You see day and night actually a lot while you're up in space. When you're going around the planet, you're going about 17,500 miles per hour in orbit. What that means is that you go around the planet 16 times a day. And 16 times a day means you see 16 sunrises and sunsets every day. So the sun, and the sun comes up 16 times as fast and goes down 16 times as fast. So when you see it, it's up pretty quick and down pretty quick. And one of the interesting things, and of course the weather is below us, so there's never anything in the way. So when the sun comes up, it's very bright, and when it goes down, it's very dark. And so a lot of the effects that you see on Earth that are caused by the atmosphere, you don't see those up in space. But it's actually, there are some unique views seeing it from space as well. And the sun, on spacewalks like we were talking about earlier, you really have to take into account where the sun is, because it can actually, if you're looking right into it as you're working on something, it can really blind what you're doing. Or when the sun goes down, if you don't have your lights on, you won't be able to see the task that you're working on. So keeping track of where the sun is actually a fairly important thing, but it also affects how you sleep, because obviously a lot of people use the sun on the ground to kind of tell what time it is. So you kind of have to get used to a new clock, because you look at the sun a little differently while you're up in orbit.
Does your oxygen level drop in space?
Your oxygen level, actually, it's all maintained. We have systems on board that maintain it. We have a whole mission control room here in Houston, and also there's one in Russia as well, that are looking at these to make sure that we have the right mixture of gases in there. So we have to keep track of that as part of a thing. So as you breathe it, obviously it drops down, but we have a tank outside that actually helps put more oxygen in the air. We have ships that bring up oxygen as well, and we can actually split oxygen, take water, we can split the hydrogen and the oxygen and actually get oxygen from that as well. So there's multiple ways to get it. It obviously goes down as we breathe it, and we just have to replace it over time. So it's something that we have to monitor continuously.
Can you watch the Atlanta Braves game in space?
Yes, you can, and that's an important thing to do. I remember when I was up in space on one of them, and I was actually, when I was on a trip, we flew over a Georgia Tech game, and they actually announced this on the news as the space station flew overhead. I didn't hear about it at the time, but when I landed, people showed me pictures where they were talking about our crew going over top of the game. But yes, they can actually put up games. They can also put up television shows that the crew wants to watch. So there are ways to do that. But a lot of times you're busy, but you could watch it, on a weekend or when you have some time, at night or something like that, get a taped view. But only for big things do you get a chance, maybe like the World Series or something, you might get a chance to watch that.
There's not a television that you can turn on and just watch whatever's on television, but the folks who work here at Mission Control in Houston can take whether it's a Braves game or the World Series or the Super Bowl or something, they can send that up to the crew members, and they can watch it on a laptop, on a computer laptop screen, so they can keep up with things like that.
And most crews request those kind of things, and we have a group here that on the ground that actually helps us get that kind of what you're looking to watch while you're up on board on orbit.
Have you seen anything unusual in space?
Not counting your crewmates.
Yeah, the things that you see in unusual in space, probably the biggest things is just how amazing the world is when you look out the window. I mean, you can really see the planets alive. You look out the window and you can see the atmosphere, you can see the blueness of the oceans. There's a lot of places you fly over on the Earth that a good chance you won't get to see in real life. And there are a few places. When I was on orbit, I saw New Zealand. It was one of the things that always flew underneath us fairly often, and I got the opportunity. I was lucky enough to go down to New Zealand later, and it was neat to compare the view that you saw from space and the view. So the things that was most unusual is seeing our planet from a different vantage point.
Yeah.
What is your favorite thing about living in space?
I'd have to say my favorite thing about living in space is really just the mission. It's one of the things I like being about an astronaut is the people that you're working with, and it's not just the astronauts that are on board the space station. It's everyone that's in the team, because when you see an astronaut in space, there's actually 1,000 people that are behind that are doing. We have a control room here. We have rooms that are actually behind the control room that support the control room and things that are going on. The people that design the hardware. You get to go out and meet a lot of these people that worked on the thing, the scientific effort. It's really just a huge, big effort, and it's really neat. And then we've talked about the international partnership that we were talking about earlier, and it's just one of those things that you have astronauts that are from different countries, you have teams from different countries, and all this is going on at the same time. When you start thinking about it, and you look at it, and then you look at the planet, and you realize there's this huge team effort and all these people involved. To me, it's probably the most exciting thing about the space station, the thing that I really think that is the coolest part about space.
How does mission control help you?
Well, mission control does a lot of things for us. They really kind of set the schedule for the day. So every day when a crew member wakes up, we have meetings the day before, and then that day they get up and they look at the things that they're going to do, and they kind of have a schedule. And a lot of times we come up with challenges where something doesn't work the way we expect, or we have like tomorrow we have a vehicle coming up for rendezvous. A lot of these things are going on in the background where the crew member is not directly involved in it, but they're keeping us informed on what's going on with those vehicles. And when you have problems, that's the ground crew. They're pretty much, we work back and forth continuously. We're constantly having discussions. We're having email traffic go up and down. We get videos that come up and down that talk about the experiments that we're working on, or the areas that we want to repair on the vehicle. So mission control is extremely involved, and it's one of the big training areas. We even have a person that we call a Capcom here in the control room that actually takes what the control room is talking about and then pipes it up to the astronauts and vice versa. So it's a very essential part of the whole mission of getting the job done.
I think we may have time for one more.
Did you ever think you'd be a pilot for NASA?
It was one of those far-off dreams, but now that I'm in this position, I really consider myself extremely fortunate to get the opportunity. There's a lot of people that apply and want to do it, and there are those out there in your group that I hope you will, if you're interested in space, will put your name on it, because just like you, I was sitting in a classroom just like you were in Georgia, and it was an opportunity to get the chance to go through. So study hard in school, look at those math and sciences, and keep doing what you're doing. And you could be sitting in this seat talking to some other people from Georgia in the future.
Eric, our time is about up. I want to thank you for joining us and providing some thoughtful answers about the job that you do.
Well, you're welcome, Pat.
Appreciate
I've enjoyed it.
And we'll send it back to the DLN.